So once again, let's start this video with this beautiful time-lapse of a snowflake. This is what we know right here on Earth, and in science it's referred to as Ice XXI, the crystalline form of water that forms a hexagonal shape, which is why it's known as H. That's practically the only ice on Earth that we usually find, which is why for many years a lot of people believe that this is what ice everywhere seems to be like. And when I say everywhere, I mean everywhere. Every comet, every planet, every nebular cloud out there. But this is an example of bias created by something that's familiar to us. We assume that ice is the same everywhere because that's what we have here. Turns out that's not the case. Turns out Ice XXI is super rare. And most ice out there, including ice on various moons like Europa and Ganymede, seems to be entirely different in its shape and seems to even contain different properties. And so, a wonderful person, this is Anton. Today, we're once again discussing different phases of ice because scientists have just discovered a new one. The phase referred to as Ice XXI, or technically XXI. A new type of ice that potentially exists somewhere out there in extreme conditions and once again has properties nobody expected. And so let's discuss this in a bit more detail, but I guess let's discuss some of the previous discoveries that once again you can find in the description and what we know about these types of ices already. But once again, a very important reminder, ice that we know is not common. It's super rare. The hexagonal ice seems to be extremely unique, and the vast majority of ice discovered on comets, dwarf planets, and moons out there seems to be entirely different in terms of structure and properties. Which of course makes water, which is a very common substance in the universe, once again a super bizarre substance that just continuously surprises us at all times. Now here's one example. On Earth, when water becomes ice, ice starts to float on the surface. And that's because water is more dense than ice, allowing the solid form to float. But that's just here. On other objects containing different types of ice, and here's a rough schematic showing us different types we discovered a few years back, the solid form is more dense, so it sinks to the bottom and even contains additional properties that make liquid water, if it exists on those objects, behave entirely different. And this is, by the way, one of the potential explanations for the existence of the magnetosphere around objects like Neptune and Uranus. Check out the video in the description if you want to learn more. And so when we take water molecules, and when we put them under pressure or various temperatures, it starts to transform into different phases. And not just like one or two, so far we've discovered 21. With many of these phases being very different in shape and structure, and importantly, different in properties. That ice and that water starts to behave very different. And so many of these phases today are referred to by their Roman numerals. Ice 1, Ice 2, Ice 3, all the way to the newly discovered Ice XXI. And in the lab, many of these phases are discovered by subjecting water to some of the most extreme pressures and temperatures that scientists can create in a lab. But today this video is all about Ice XXI, or I guess XXI. All of this is described in this study from Nature magazine by Yoon Hee Lee and the team you see here. And this new phase provides us with incredible insights into what happens deep inside icy moons and distant planets, even the ones in other star systems, because we do believe these types of ices exist in very highly pressurized conditions. But to understand why Ice XXI is such a big deal, let's briefly discuss high-pressure physics. Okay, so Ice XXI is what we have on the surface of the planet, but on objects like, for example, Ganymede or Europa, or even the super exciting moon like Titan, most of the water ice is under the surface under pressure, and especially in ice giants like Neptune and Uranus. And so decades ago, when Voyager 2 probe flew past Uranus, by measuring the magnetic field, which was very unusual, very unpredictable, and highly misaligned, researchers realized that to explain this magnetic field, we had to rely on new physics and new understanding of the magnetic dynamo, because none of the explanations from our own planet or even from planets like Jupiter and Saturn seem to explain any of this. And so unlike Jupiter and Saturn, where the magnetosphere seems to be the result of extremely pressurized metallic hydrogen, here these unusual magnetic fields, that were mysterious for a very long time, eventually were explained through pressurized water. And so at extreme pressures of 500,000 atmospheric pressures, water seems to transition into superionic state. It basically becomes an entirely different substance. And it's in this bizarre state where the oxygen atoms, strangely enough, form a solid cubic structure, or basically they become crystallized, but the hydrogen atoms inside water start to float around as if it was some kind of a liquid or even a metal. And this free flow of hydrogen then creates powerful magnetic fields. And though at first this was just pure theory, eventually scientists discovered how all of this seems to form. This led to the discovery of what's known as Ice XVIII or superionic ice that was actually only discovered a few years back, and we'll discuss this in detail in one of the videos in the description. And because of this discovery, a lot of scientists jumped in and wanted to find more additional forms. And pretty quickly researchers found Ice XIX, a form related to Ice VI, that though structurally similar was very different in conductivity, but that also kind of made sense in the context of Neptune and Uranus, because it may also form inside these planets under certain conditions. But I guess now let's discuss this new discovery. So, Ice XXI. Although I guess a super quick side note. You might realize that Ice XX seems to be missing, but this was also discovered a few years back and is technically a superionic phase of ice that's directly related to Ice XVIII. And actually, once again, both of these phases potentially exist inside Neptune and Uranus. Anyway, so Ice XXI. And this new ice phase was discovered using modern powerful equipment, and specifically European XFEL, the world's largest X-ray laser, which represent top-of-the-line equipment when studying highly pressurized conditions. And so to create these exotic conditions, researchers used a tool known as dynamic diamond anvil cell. It kind of looks like this, and is literally two diamonds, which is of course an extremely hard to break material, that are then used to squeeze something between them in order to produce something under extreme pressure. And so here imagine taking a very tiny water sample and squeezing it between two tips of diamonds. This allows them to apply immense force, pressurizing the liquid droplet to about 2 gigapascals, so 20,000 times the atmospheric pressure. But here they apply this pressure super fast, within just about 10 milliseconds, and then slowly released it over 1 second to see what happens. And so during these compression and decompression stages, an X-ray laser was used to detect molecular changes. This is kind of like a high-speed camera taking pictures, which you can basically see right here. And so with over 1 million images per second, they could see exactly how crystalline structure changed. And this is how they discovered this new Ice XXI. A new phase of ice that seemed to exist in very special conditions, and that's never really been seen before. But the most unusual fact about this ice is that it was identified in room temperature conditions. Unlike previous ices, this didn't require super high temperatures or super low temperatures, and was basically formed at approximately 20 degrees Celsius. And so under very high pressure conditions in room temperature, water becomes super compressed and rapidly crystallizes, forming a very distinct structure from anything we've seen before. This is very different from all known phases. And here it seems to have tetragonal structure. So kind of similar to what you see behind me, but not exactly the same, made out of 3 perpendicular axes, where 2 are usually equal in length, but the third one has slightly different length. And this is somewhat similar to things like zircon, for example, which often contain these tetragonal structures as well. And here it seems to be built out of surprisingly large repetitive units or unit cells, but strangely enough, all of these unit cells are built out of 152 water molecules. So here it contains these repetitive 152 atom structures, but here it's not entirely stable. It's actually metastable. This means that it exists for a period of time, even though another form of ice, in this case Ice VI, would very likely be more stable under these exact conditions. And so if left alone, it's probably going to collapse into something a little bit different. And the formation of this metastable ice suggests that the water molecules, when rapidly compressed, don't immediately jump into the most stable form, and actually take these intermediate steps first. And so the Ice XXI probably becomes Ice VII first, and then becomes Ice VI. But the real importance of this study is in trying to understand the pathway to this crystallization. And so right now the study suggests that Ice XXI is some kind of an intermediary stage to eventually becoming Ice VI. You can kind of see Ice VI squeezed between different phases of ice in this picture. But additionally, scientists also discovered that a lot of this super compressed water seems to transition into Ice VI through a lot of different phases first. Actually, at least 5 different phases. And so this could be Ice XXI, it could also be Ice VII, or maybe even Ice XV. And this means that deep within planetary bodies like Neptune and Uranus, water is not following a single predictable freezing path. So unlike our planet, where water just crystallizes and becomes like a snowflake or a chunk of ice, on a lot of other planets, so once again Neptune and Uranus, and by the way this is the most common type of a planet we've discovered so far in the entire galaxy, inside many of these objects, many of these metastable ice phases potentially exist and transition from one to another, And on top of this, many more phases probably exist that we still have not discovered yet. And so just to rephrase this, in a lot of these objects, water ice does not just remain the same, and seems to transition from different phases depending on the pressure, with each of them having different properties and behaving in very different ways. So some of them might be conductive and produce electricity and thus the magnetic field, some of them might suddenly become super dense and start sinking and thus experience more pressure, whereas some of them might even start glowing or something. So right now we just actually don't even know what a lot of these phases do. But here there's also an important comparison to Ice 1H or Earth ice. As you probably remember, H stands for hexagonal. That's the shape of the crystal. But the main feature in this crystal is that hydrogens, as you can kind of see them right there, are more or less disordered. They're not aligned in the same way and they always point in different directions. And as a result, ice on Earth has a lot of unique properties like the ability of glaciers to slowly flow. But in contrast, a lot of exotic ices like 9, 15, 19, and most likely 21 seems to have hydrogen that's always ordered, with many of the atoms stacked in a very specific orderly crystals. And so inside Ice 21, that also seems to have a very similar structure, it seems to be able to pack many more atoms of hydrogen in the same space, with the hydrogen then producing additional effects, including magnetic effects. But the question here is, okay, so why exactly does this matter? Well, by studying these phases of ice and by trying to understand them, we do gain a lot of vital information about the physics of water, the most important substance on Earth, and especially water under extreme conditions that are obviously very common in the universe. But mostly this is important for space sciences. For example, ice giants like Neptune and Uranus, with their very complex layer structure and their very unusual magnetic fields, seem to be entirely governed by very dynamic interplays between very different and very bizarre phases of ice. Ice under extreme pressure. Likewise, many icy moons, Ganymede, Titan, Europa, and a lot of dwarf planets as well, are also believed to contain other ice, the more stable Ice 6, with the much deeper interiors potentially being affected by metastable phases that may exist for some time but not always, and may produce additional effects, including once again magnetosphere. And this is something that we know Ganymede, for example, seems to have. On top of this also influences their overall flexibility and their structure, because this type of ice is very different from Earth ice, even in the way it moves and flexes. And so the complexity of all of these ices hints that the internal composition of many of these worlds is far more varied and active compared to any traditional model we used to have. These are truly alien worlds. And obviously this has a lot of implications for the potential extraterrestrial life. Here, even if we find water on these objects, unless it's in liquid form, it's possibly not exactly the same ice as what we're used to. And so understanding how water molecules stack, shift, and transition under pressure is quite crucial for many fields of science. And so every new phase discovered, whether the strange supersonic ice, the widespread amorphous ice that seems to be literally everywhere in the universe, or this newly identified Ice 21, reinforces the idea that our hexagonal Ice 1H, with its very specific unique properties and properties that seem to benefit life on Earth, is actually an anomaly, making Earth once again just a little bit unique. And this, of course, raises this very important existential question. Is the uniqueness of this hydrogen-disordered Ice 1H, or Earth ice, and the water that it produces, what made life here on the planet possible to begin with? So basically, is this ice, with its strange structures and strange properties, the reason we exist? Now, we don't have the answer yet, but the implication is definitely there. But obviously, the journey does not end here. Researchers are already talking about the search for the next unknown phase, Ice 22 in this case, trying to figure out how exactly it's going to form, and what unique hydrogen patterns it's going to produce, and what structure of oxygen is going to produce as well. Which means that this might be an endless process. There might be a lot of different phases ice produces, and we may have just scratched the surface at this point. And that means that we still know so little about the most essential substance on the planet, water, and we still don't really understand it very well. But for the field of high-pressure physics, this is already super exciting. Being able to achieve this is a tremendous success, and provides scientists with new tools for this type of research involving metastable substances. And so on that note, once the researchers discovered the Ice 22 or a bunch of other ices, We'll talk about this in some of the future videos. Until then, check out the previous videos about other ices in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access and a few additional videos. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.